All right. Hey, everybody. This is Larry. I'm doing another virtual contest. Just because, well, I missed the earlier one because I didn't was not around the computer at 10 a.m. But this is going to be practice for the one that's later today in 3 hours. So wish me luck, and then I'm gonna just use this as a practice. All right, cool. Ready? Okay, cool. Okay, cool. All right, just commenting on myself now. I think ready. Uh, yeah, the first thing I noticed on this problem was that well, I was just thinking about like, because this is very similar to some problems I've solved on Leetcode. So I was just thinking about what does it mean to be a arithmetic progression. I know that something I learned recently was about like some dynamic programming related thing, but this isn't easy. So I think the thing that I did notice is that yeah, the the missing value cannot be the first or the last element. So that means that the delta has to be either the difference between the first two elements or the last two elements, right? And we just try to fit that in, and if it fits in, then yeah, if it fits either of those cases, then it's true. And this is where I started coding. Did a little bit of copy and paste there here. I probably could have done a little bit better on kind of modularizing it a little bit, but it's easy, and I just wanted to get it out as quickly as possible. This is a proof of concept, and if it's wrong, then it's just wrong anyway, right? And in this case, we only need to copy and paste once. You only see it twice, so yeah. Let's see what he does here. I think that was my general thought process to begin with. Yeah. Oh yeah. Also, at this point, people keep on texting me, so which I appreciate once in a while, but but sometimes it's a little tricky. Um, yeah, I think I actually didn't even need this variable, but I was just trying to think maybe I could reuse it in a clean way later. But I think like right about this exact moment, I was like, wait, um, we actually could do better than that if there's a number that's missing. Because I was going to do something like do another pass of like, well, this is the missing number. Is this valid? But I was like, oh, actually, if there's the numbers missing, then that means that this number fills in between the last number and the current number, right? Um, so I think that's how I kind of came around this early return statement. Um, yeah, and then I just did it again with like the last two numbers. That's how I kind of thought about it. Yeah, and then literally here, I just copy and paste because I think this is mostly good enough, assuming that is correct. Unfortunately, at this point, this is when I submit, I think. I don't know why I chose negative. I mean, I think I just didn't think that was a possible thing to return to -1, so I submit about nowish. Okay, well, maybe I ran one more time. um, Look at me, very deep in thoughts. Um, yeah, I mean, when you see this wrong answer, it's very clear that I did not take account the case where all the numbers are zeros, or sorry, all the numbers are the same, so the delta is zero in between numbers. And here I'm trying to think like, do I do something clever to check for it? Do I, and I was trying to think if there's another case where this may come up um, where it doesn't, but instead I just kind of be like, okay, I think this will only come up with the delta is zero. That means you return the first element because they're all the same anyway. Okay, and then that's where I submit it, and I jump to the second one because time is of an essence. Right now, I was impressed that
Sorry.
someone got another problem, but and he's coughing. Definitely need to have one of those cough drops on it on. But yeah, so this meeting scheduler is a very straightforward problem in theory, mostly because I've seen it seen similar problems recently-ish, but it's an event-based problem. Also, I think, to be honest, a variation of this is something that I've asked on an interview before. But yeah, so the solution here, I think I knew immediately, but I was just looking at the constraints just to make sure, and like how the input is structured and stuff like that. I thought about doing C++, but I was like, whatever. Do Python so we could sort tuples very easily instead of doing all this makeshift pair or make pair shift stuff. And I chose Python because, yeah, it seemed like the thing to do. So that I could do I mean, you'll see how when I coded that it's very straightforward, which is that, and you know, there are only two types of events on the people scheduling side. There's only an availability begin event and an availability end event. And that's what I create here for slots 1 and slots 2. And minus the input out, minus setting up the input, this actually scales really, very well with the number of people you need to check. And now that we have all the events, I'm thinking of putting into an array. Well, we have to sort it first. You're right. Thanks. Oh, Larry. Past Larry. I guess I'm the old Larry, actually. But yeah, now we look at the events, and for every event, we just kind of count the number of current occupants that is available to kind of be in this event, right? And yeah, and if the number of people that are currently available is 2, which is the number of people we're trying to match, then we just set that as the starting time, and then we want to know when that time ends, which is when it goes from 2 people to 1 person, which it always has to because it can jump. At least the way we structure it, and maybe with some kind of path compression you could do it. But yeah, and this is where I'm just trying to make sure that there's no other way of doing that kind of event. And then now I check that, okay, so that's the availability from the previous start to the current start. So what does that mean? Well, if it's longer than duration, or as long as duration, then it's good, right? That's essentially right here. Unfortunately, if you caught that, then yeah, which is that I had an off by 1, which I think at some point I knew to check for this. Or I thought about I made a mental note to check for it, but I forgot about the off by 1 error, which will cost me 5 minutes in submission penalty. And you see that in a sec. When I submit it, because I ran this just in case. I always run the examples generally, unless like I'm really, really confident about it for whatever reason. And as I saw this, I was like, okay, there's an off by 1, which I forgot to handle. So that was unfortunate. Yeah, knew I need to test that case. You knew it messed up, but yeah, and then it got accepted after we fixed that case. Checking the rankings here. Usually, I don't think I check the rankings that often when I'm in a live one, but on a virtual contest, I probably care a little bit less. Okay. Oh yeah. So this one is yeah. I mean, I think the analogy I would think about is that this is essentially the same as coin change. Kind of in that, and you could do this in n square, but essentially, yeah, coin change, except for that with, yeah, except for that instead of the number of coins is, or sorry, the number of possibilities is just the probability of possibilities. If that makes sense. Maybe I'm saying it weird, but and there is some probability kind of knowledge that is required in this problem, which makes it a little kind of weird. But I mean, it's relatively basic probability, but it's still, I don't know, just like one more hurdle that if you're not familiar with, then you have to like prove to yourself and stuff like that. The key word here, I think, is the linearity of expectations, meaning, you know, you could sum expected values and such, Here, oh yeah, here I'm just setting the dynamic programming away. I think initially I thought about doing this as 1D, or not 1D, but just O of n space. But then I was like, n is 1,000. I don't want to think about kind of the edge cases possibly. So I just try to type it out as soon as I can, um, and it's just initializing it. And then we set the base case. I think. I hope. I mean, I got it right eventually. So I think that's right. I'm just trying to. At this point, I'm just, I guess, looking at the code, but being deliberate about it. And that's my base case where if you have no coins, you have the zero heads will be one. I think I go over this problem a little bit later after the contest, but essentially, if you have trouble with this one, I would recommend looking into coin change. Yeah, I think the key kind of observation is that you always only care about the previous array, so dynamic programming array or cache array. So you only have to look at the last two arrays. So that's how you could get the space length of n. But as I said, it did not cost me anything to use n square matrix, so that's what I did. Yep. And I'm just typing it out and kind of looking at the targets. Oh yeah. I think at some point I did. I mean, at this point, I conflated targets and the number of coins a little bit. So this returned the wrong answer for me, and this is why we always won custom test. Oh yeah, actually before that, I thought about like what does it mean to be 0, and then that's what I had to double check that. Actually, I mean this would have been caught by the example test thing as far as I know, but as far as I mean, looking back onto it, but it's good. I mean, I definitely should fix it in my colors. Just an edge case. And then I think here we won the test, and I'm like, oh, well, one coin is right, but thankfully this gave me accurately an incorrect answer. I'm like, huh, what am I doing wrong? Why is this one? One is just ridiculous. But then I was like, oh wait, I'm mixing target and numbers, of course. This is an easy fix. Maybe that's why it took a little bit long. You have to fix the return regularity. Okay, there you go. There you go. Okay. Okay, and now I have to wait a little bit of time because I've been running too much. And also, with these things for me anyway, sometimes I have off by 1 hours, but usually they're easy to fix because they're just returning the wrong return values. And at this point, I was like, that seems pretty confident, but I took an extra time to write one more test. This is not a great test, actually, to be honest, but just to prove to myself, because I don't know, I didn't think there was that many edge cases on this one, to be honest. But I did kind of have 2 submission errors, so I was like, okay, let's do a little bit more if you can do that. Okay, divide chocolate. Oh yeah, so this one reminds me of that classic bookshelf problem, I think it's called, or something similar, where you have a bookshelf. Sometimes it's the height, or sometimes it's the width, but you have to minimize the maximal height, or something like that. That's where my mind went to initially, and that is based off a greedy, like given a certain, I guess in this case, a total sweetness, how many pieces can you break that into so that like the smallest piece is at least X sweetness. And once you have that, then so you solve that problem by greedy because, well, if it goes over that, then like you have to cut it, right? You have to chop it off and give it to the next. But yeah, and then from that you just binary search over all the possible values. I have a mistake here, which is that for my binary search, I set my high bound, if you will, to just the n, where the n is the input size, which is clearly wrong, and I think that cost me another 5 minutes, as you'll see as this comes up, which is unfortunate. But yeah, right now I'm just implementing what I already mentioned. I was also kind of thinking about the possibilities uh, earlier before I implemented or started coding. I thought also about dynamic programming, in which it's just you because it's just suffix, so there's an n square solution for dynamic programming, but obviously it's a little tricky because the dynamic program solution is n squared, but n is 10 to the 4th, which is 10,000. So it's a little bit tight. Probably going to time limit. So I didn't really consider that much, but I thought about it a little bit. And this is just how I do the binary search. But because I set the high bound to be incorrect, there's some like weirdness that I try to fudge around it. And as and a little bit unlucky, to be honest, because for this particular problem, all the test cases worked in the weird way that I hacked it together, which is a little unfortunate, because you want, like ideally I would want something that gives me or let me know that my solution is wrong very quickly, right? Yeah, and now I'm doing, so that's the binary search part, and now I'm writing the greedy part. Uh, that part is straightforward. So what I'm doing here actually is that every piece has to be at least uh, the value that we put in. So that's what we check for. And if that's the case, what is that will also be the smallest piece. So I played around with this. I don't know what he just said there. Just made some mumbling sound. um, yeah, yeah, I had it off by, or like it felt like it was very close, but at the end of the day, I had a little bit of an issue. So I kind of fudged this. Well, yeah, at this point I did off by one. I'm just trying to think like, what does that mean to go off by one? But that one is a little wrong. But they gave me the right answer somehow. Very unfortunately lucky, or whatever. So I submitted it, gave me the wrong answer because it's very obvious. I was like, 6? What? In what world does a 6 make sense given these inputs? And then I realized that my upper bound is actually the array size instead of like some ridiculously big thing.
Oh.
Yeah, see, realize that right now. Oh, past that. Now here I'm trying to find the bound bit, and then I think I saw this 10 to the 4th and 10 to the 5th. The 10 to the 4th elements, each of them going to be 10 to the 5th. So I was like, 100,000 is actually not going to cut it. So I made it to a billion. I think, yeah. Yeah, and now I'm just trying to think about, and some of this is because I made a hack earlier that I had to kind of change back so that it works. I was like, that number, I mean, it made more sense than the 6, but it's not quite right still. silly mistakes aside, it did okay. I mean, this isn't going to stand because I have 3 penalties, but question is whether I could replicate this on the actual contest later. I mean, some of it is that, like, when you're practicing, you don't have the pressure of like things digging into you and try to rush things a little bit. I don't think I was rushing it that much. I just had silly mistakes. I mean, feel good about self. I mean, time, like programming time wise, I did okay. Like I solved everything in 20 minutes. It's just that I had 3 errors. So the wrong submission cost me 15 minutes, which is almost double my coding time. But it seems like it's a very error-prone contest. Like some of the top fast people also got many mistakes as well. But yeah, overall a fun set. I think that like every bug I had. Yeah, I mean this is gonna go down. So let me just run for the problem and then we'll see where I end up. But like I feel like I did okay. I just keep there were very silly mistakes on the things I did. This one, yeah, I mean I just didn't take account the progression being all the numbers being the same, so the delta is 0 between array elements. What I did here was because the first and the last value is always going to be an array, so you just take the delta. So you know that because there's only the 3 elements, you know that it's always going to be true that the correct delta is either the difference between the first 2 numbers or the last 2 numbers. So I kind of used that and then kind of like, hey, if it's not that delta, try to fill it in, and if you fill it in and then and that bridges the gap, then that's okay. Did it twice, but I forgot the 0 case. That's unfortunate. And something that I should have gave a little thought about. Let's see my timing. This is a weird bug with virtual contest, but that's okay. Sometimes refresh goes on. I mean, I did in 4 minutes. Maybe, like could I have gotten it if I taken slower time? Probably, but I think sometimes with Yeezys, I just rush them because I just assumed, because usually you just get them right on the first try. By you, I mean, I guess that's the level I'm practicing on now. Definitely, I mean, if you're competing in contests, I guess that's what I've been optimizing for. But yeah, still, yeah, I feel like I also made that mistake on previous ones with arithmetic progressions. So definitely something I need to keep in mind about on the real contest. So I think like I probably will max out my rating gain anyway, so it probably doesn't matter that much as long as I finished high-ish. Meeting scheduler, did I think this one? Oh, I did get it. What did I get an error on? Off by 1. Okay, yeah, this one it was. I think okay. I mean, so this is just a event sorting thing for me. Just go for the event and I think my solution actually, minus some hard coded constants. I could have yeah, I mean, it's very generic. I could have made it more than for 2 people even. Didn't even look at the constraints that much because I think I solved a similar problem maybe recently-ish. But my one bug was that I didn't take account I just have it off by 1 because on this case I knew I should have tracked it. I was thinking about it while decoding, but I forgot it before I submitted because I was a little too confident about it, or just rushed it to it. I was confident, never confident about these things, but probably rushed it a little bit. Like I did it pretty quickly too, because it seems pretty straightforward in theory. Because basically what I did is, each schedule opening, I just set it so that you could set as an event of like, the beginning of an interval, and if that interval has all the people, which in this case is only 2, then we set it as a possible start. And then this statement is if now there's only 1 person, but the event is -1, meaning if it went from 2 person to 1 person, that means it's the end of a possible availability. So I checked to see if the length was long enough, and if it's long enough, then we just return it. Unfortunately, I had a off by one error that cost me minutes, but I don't know. Overall, okay. I mean, yeah, I mean, I need to be better about that, but in terms of like, understanding the problem, that's all you could have hope for sometimes. Toss strange coins. I think I did this one okay, right? Okay. Actually, surprised it took. I mean, it's that 5 minutes. Surprised. I mean, because I knew how to do this right off the bat, so I feel like maybe I could have been a little bit faster. But like, what's the difference between a minute or two? Because seems like maybe I rush things and it cost me 5 minutes anyway, right? But here, yeah, this is a. I mean, you could have done it deep, bottom up or top down. I did this bottom up because this is a variation. Similar. I mean, the actual coding and understanding is a variation of like the coin change or coin counting stuff, where you try to count the number of possibilities in like reaching a certain sum or something like that. Like the only difference is that you have to understand a little probability, which is the main one being linearity of expectations, and then everything else follows in the sense that I mean, you could have even. I mean, I knew this while I was doing it, or maybe even beforehand. But for these problems, I don't try to prematurely optimize unless I have to. And in this case, I didn't. So I did the n square space one, or you can optimize the O of n space. But yeah, and you have to maybe. No, I mean, I think this is a relatively trivial thing to optimize, but I just didn't even want to think about it and just forget it, right? If it saves me 20 seconds, it saves me 20 seconds, right, when it comes to a contest. But on an interview, you should probably take that time to at least articulate that thought. But basically, yeah, so we roll n coins, or we flip n coins, not roll. And each of these is just the probability of I mean, it's just like a binary, right? 1, 0, and 1. So this is the probability of, okay, we're flipping a tail in this case because it counts as a 0, which is, you're given the heads probability. So, and then this is the plus the probability of flipping a head and then adding 1. And at the end, you just return it. I think for me, sometimes I have an off by 1 here and there, which I think it's okay. I mean, like, you could correct it relatively quickly generally. But yeah, I mean, overall, I would recommend reading up on coin change if you have problems with this one. The white chocolate, yeah, I mean, I think this one is, for me, my philosophy is the one on the, I call it the bookshelf problem. I actually don't know what I don't actually remember the proper name for that. Maybe that is the name for it. But basically, the bookshelf problem is the problem where bookshelf problem is the problem where you have a book of various, sometimes height, sometimes width, depending on the problem set, and you wanted to some variation of like minimizing the max of the heights, so that you could get a good bookshelf, or sometimes the width or something like that. But the idea that is shared about all of them is just like binary search. Well, so the idea is that it's greedy and a binary search because you're only doing chunks, and the value of the chunks is always going to be the value of the chunks is always going to be consecutive. So where you make the cuts matters. I think there may be a dynamic program solution, but I'm not actually. Yeah, because you could just think about a suffix. I mean, I don't know if you could do it for this farm only because it's like 10,000. So maybe it's a little tricky because there is definitely or maybe I don't know about definitely, but there is possibly a n squared dynamic program problem based on k and the array index, and you just because it's maybe a suffix thing. I think that's probably a solution too, but well, it's a solution in that other case, but because 10 to the fourth is too high. To be honest, 10 to the fourth square is too high. That is. To be honest, I didn't really consider that solution that much, only because I don't know, my gut said and this is related to the bookshelf problem, and this time my gut was okay. What did I get it? I have a submission error, right? Okay. What did I submit? Oh yeah, I mean I just misread the silliness. I set the binary search tail to be just the length of the array, which somehow passed the sys I mean I had some off by one errors that combined to kind of pass the testing, which is sometimes like sometimes it's unfortunate. It's lucky and unlucky. But as soon as you get a case that's bigger than these numbers, it was clear that it was wrong. So but it was also fortunate that it was easy to fix. I think I actually one tricky thing I had to figure out was what to set the maximum tail is. And I had to do this math about 10 to the 50, 10 to the 4th, or maybe this is test, I don't use it, but which is 10 to the 9, right? So that's why I set it this way. But yeah, so that's kind of how I talk about it. Let's see if my rank changed enough. Because I don't think I talked to 15 minutes, and this will, because I had 3 hours, will keep on going down for 15 minutes, right? So, I mean, I don't know. I'm not going to wait around for that or make you wait around to watch me do that. But cool. Hopefully, I mean, this wasn't a real, I mean, this wasn't a real contest for me per se. So, which is on, I mean, I did well. This was a real contest, minus some silliness on the mistakes. And it's coming up there anyway, I guess. But yeah, hopefully this prepares me for the contest later today in a couple of hours. So anyway, see you. Thanks for tuning in.